Hey everyone, welcome back to my channel, Learning Life Content. Like, share and subscribe to stay updated with our latest explorations and discoveries. Today we're embarking on an epic journey to delve into the fascinating and often overlooked world of moons within our vast solar system. Now, you might be thinking moons, those seemingly insignificant celestial sidekicks that orbit around planets, but let me tell you, there's an entire universe of complexity and wonder hidden within these cosmic objects that goes far beyond what meets the eye. We're going to be diving deep into the intriguing concept of moon families, a topic that reveals the interconnectedness of these celestial bodies. You see, just like on Earth, where we categorize families based on shared traits and ancestry, we can apply the same principles to moons, grouping them into families. By meticulously studying their composition, intricate orbits, and even their unique and quirky features, we can start to piece together their family histories and understand the processes that led to their formation. Believe it or not, these moon families hold incredible clues about the formation and evolution of our entire solar system, acting as windows into the past. They're like cosmic time capsules, preserving secrets from billions of years ago, offering us a glimpse into the ancient history of our celestial neighborhood. So, buckle up and prepare yourself for an in-depth exploration of the captivating world of moon families with me. Trust me, you won't want to miss this cosmic adventure as we uncover the mysteries and marvels of these fascinating celestial families. Now let's delve into a truly fascinating and intricate aspect of moons, their profound influence on the planetary systems they inhabit. You see, moons aren't just passive celestial bodies hanging out in the vast expanse of space. They play a crucial and dynamic role in shaping the very planets they orbit, influencing their characteristics and behaviors in myriad ways. One of the most significant and observable ways moons exert their influence on their parent planets is through the phenomenon of tidal forces. These gravitational interactions, which are a direct result of the moon's pull, can create tides in a planet's oceans, as we see so vividly with our own moon and Earth, where the rhythmic rise and fall of ocean tides are a testament to this celestial dance. But the impact of moons on their planets doesn't stop at just creating ocean tides. Tidal forces can also generate significant internal heat within moons and planets, driving geological activity such as volcanic eruptions and geysers. This internal heating can lead to spectacular displays of volcanic activity, as seen on Jupiter's moon Io, where intense tidal forces result in continuous volcanic eruptions. Additionally, moons can play a pivotal role in stabilizing the orbits of their parent planets, ensuring that these planets maintain a consistent and predictable path around their star. This orbital stability can be crucial for maintaining a planet's climate over long periods, making it more hospitable for life by preventing extreme variations in temperature and environmental conditions. In some extraordinary cases, moons can even contribute to the creation of new worlds, playing a role in the formation and evolution of planetary systems. For instance, the intricate gravitational interactions between moons and their parent planets can lead to the formation of stunning rings and smaller moonlets, adding to the intricate and mesmerizing dance of celestial bodies. This cosmic dance of moons and planets is a mesmerizing example of the universe's inherent order and complexity, showcasing the delicate balance and interplay of gravitational forces. The gravitational ballet they perform not only shapes their own destinies, but also exerts a profound influence on the entire solar system, affecting the orbits and interactions of other celestial bodies. So, as we embark on the exploration of the moons within our solar system, let's remember that these celestial companions are far more than just cosmic sidekicks. They are integral and dynamic players in the grand theatre of the universe. They shape and influence the worlds around them in profound and intricate ways, contributing to the dynamic and ever-evolving nature of the cosmos. Now let's move on to our first family portrait in this cosmic reunion, where we will explore the fascinating relationships between planets and their moons. Let's kick things off with the colossal giant of our solar system, Jupiter, and its extensive entourage of moons. Jupiter boasts an impressive 79 known moons, but we'll focus on the most significant ones, the Galilean moons, Io, Europa, Ganymede, and Callisto. These four celestial bodies were the first moons discovered beyond our own, marking a monumental moment in astronomical history. First up, we have Io, the ultimate rebel of the group. This fiery moon is a volcanic wonderland, boasting more active volcanoes than any other object in our entire solar system. making it a geological marvel. Next, we have Europa, often referred to as the icy queen of the Galilean moons. This moon is enveloped in a smooth, icy shell adorned with mysterious cracks and ridges, hinting at dynamic processes beneath its surface. Scientists are particularly intrigued by Europa because they believe that beneath its icy exterior lies a vast, salty ocean that could potentially harbor extraterrestrial life. Now, let's turn our attention to Ganymede, the giant of the family. This behemoth is the largest moon in our solar system, even surpassing the size of the planet Mercury. Remarkably, Ganymede also possesses its own magnetic field, a rare and fascinating feature for a moon. Last, but certainly not least, we have Callisto, often dubbed the Ancient One. This heavily cratered moon serves as a time capsule from the early solar system, preserving the scars of countless asteroid impacts over billions of years. Can you believe the incredible diversity found within just one moon family? It's like a cosmic reality show featuring volcanic eruptions, hidden oceans, and giant moons, each with its own unique characteristics. By studying these differences, scientists gain invaluable insights into how these moons formed and evolved over billions of years. For instance, Io's intense volcanic activity is driven by the powerful gravitational pull of Jupiter and the other moons, creating immense tidal forces. Meanwhile, Europa and Ganymede likely harbor subsurface oceans, kept warm by the same gravitational forces through a process known as tidal heating. The Galilean moons demonstrate how studying moon families can unlock incredible secrets about the formation and evolution of our solar system. Each moon tells a unique and compelling story, helping us piece together the complex forces that have shaped our cosmic neighborhood over eons. Now let's shift our gaze to the jewel of our solar system. Saturn, the ringed wonder, this gas giant with its stunning and intricate ring system, has captivated astronomers and stargazers alike for centuries. Saturn's rings are truly a sight to behold, a mesmerizing display of countless icy particles, ranging in size from tiny grains to massive chunks. These particles, composed primarily of water ice, reflect sunlight, creating a dazzling spectacle that can be seen even from Earth with a small telescope. But did you know that these rings are intimately connected to Saturn's moons? The relationship between the rings and the moons is a complex and fascinating one, with each influencing the other in a delicate cosmic dance. You see, Saturn's rings aren't just a pretty face, they're a dynamic and ever-changing system, constantly shaped and sculpted by the gravitational influence of Saturn's moons. These moons, ranging from tiny moonlets to large planet-sized bodies, exert gravitational forces that create waves, gaps, and other structures within the rings. It's like a cosmic ballet, with the moons playing the role of choreographers, guiding the movements of the ring particles. The gravitational interactions between the moons and the ring particles create a constantly shifting and evolving pattern, much like the intricate steps of a dance. One of the most important groups of moons in this cosmic dance are the shepherd moons. These small moons, often only a few kilometers in diameter, play a crucial role in maintaining the structure of the rings. These small moons orbit within or near the rings, their gravity acting like invisible fences, keeping the ring particles in line. Without the shepherd moons, the rings would quickly disperse and lose their distinctive shape. Imagine them as cosmic sheepdogs, herding the rings and preventing them from spreading out. The shepherd moon's gravitational influence creates narrow gaps and sharp edges within the rings, adding to the overall complexity and beauty of the ring system. But Saturn's moons aren't just ring keepers, they're a diverse bunch with their own unique stories to tell. Take Enceladus, for example. This small, icy moon has captured the imagination of scientists and space enthusiasts alike. This small, icy moon is one of the most exciting places in our solar system because it's home to giant geysers that erupt from its south polar region, spewing water vapor and organic molecules into space. These geysers are a window into the moon's subsurface ocean, which lies beneath its thick, icy shell. These geysers are thought to originate from a vast salty ocean that lies beneath Enceladus's icy shell, much like Europa. The presence of water, along with organic molecules, makes Enceladus a prime candidate for the search for extraterrestrial life. And just like Europa, Enceladus's ocean is considered a prime candidate for life beyond Earth. The combination of water, organic molecules, and energy sources from the moon's interior creates a potentially habitable environment. Imagine that, a tiny moon spewing out evidence of a potentially habitable ocean. The discovery of these geysers has sparked a renewed interest in the search for life in our solar system, and Enceladus is now one of the top targets for future exploration missions. Then there's Titan, Saturn's largest moon and the only moon in our solar system known to have a dense atmosphere. Titan's thick, hazy atmosphere is composed mainly of nitrogen with traces of methane and other hydrocarbons. Titan's atmosphere is so thick that it's actually denser than Earth's, and it's composed mainly of nitrogen, just like our own. This dense atmosphere creates a unique and intriguing environment with weather patterns and surface features that are unlike anything else in the solar system. But here's the twist. Titan's surface is incredibly cold, with lakes and rivers of liquid methane and ethane instead of water. These hydrocarbon lakes and rivers create a landscape that is both alien and familiar, with features that resemble those found on Earth but composed of entirely different materials. Imagine a world where methane rains from the sky, forming rivers that flow into vast methane seas. The weather on Titan is driven by the same processes that drive weather on Earth, but with methane taking the place of water. It's like something out of a science fiction novel, yet it exists right here in our solar system. The exploration of Titan has revealed a world that is both strange and familiar, with landscapes that challenge our understanding of planetary science. But Saturn's moon family doesn't stop there. Each of Saturn's moons has its own unique characteristics and stories to tell, adding to the rich tapestry of the Saturnian system. There's Mimas, the Death Star moon, with its giant impact crater that makes it look eerily similar to the infamous Star Wars space station. This crater, known as Herschel, is so large that it gives Mimas a distinctive appearance, making it one of the most recognizable moons in the solar system. And then there's Iapetus, the yin-yang moon, with one hemisphere as bright as snow and the other as dark as coal. This stark contrast in surface brightness is one of the most striking features in the solar system, and it has puzzled scientists for decades. Each of Saturn's moons, from the tiny shepherd moons to the giant Titan, plays a crucial role in the ongoing evolution of the ring system. Their gravitational interactions create waves and gaps in the rings, sculpting them into the breathtaking structures we see today. These interactions are a testament to the dynamic and ever-changing nature of the Saturnian system. So, the next time you gaze upon Saturn's magnificent rings, remember that they're not just a static feature, but a dynamic and evolving system, shaped by the intricate dance of gravity and the fascinating stories of Saturn's lunar entourage. The Saturnian system is a microcosm of the complexity and beauty of our solar system, a reminder of the wonders that await us as we continue to explore the cosmos. Chapter 3. Uranus and Neptune, the icy outliers and their moon mysteries. Now let's embark on a journey to the farthest reaches of our solar system, where the majestic ice giants Uranus and Neptune hold dominion over their distant realms. These remote and often overlooked worlds are home to their own captivating families of moons, each one possessing a unique narrative that adds to the rich tapestry of our cosmic neighborhood. Uranus, often referred to as the sideways planet, is distinguished by its extreme axial tilt, which is nearly 90 degrees relative to its orbital plane. This extraordinary tilt results in Uranus experiencing some of the most extreme seasonal variations in the solar system, with each pole basking in continuous sunlight for decades, only to be plunged into prolonged darkness for an equal duration. This peculiar axial tilt also influences the orbits of its moons, which revolve around Uranus in a plane that is almost perpendicular to the ecliptic plane of the solar system. Imagine a family portrait where everyone is standing sideways, defying the conventional orientation. That is the reality for the moons of Uranus, orbiting in a manner that seems almost surreal. This unusual configuration is believed to be the consequence of a colossal impact event in the early history of Uranus, which not only knocked the planet onto its side, but also scattered its moons in a manner reminiscent of billiard balls on a cosmic table. Despite their unconventional orientation, the moons of Uranus are a diverse and intriguing collection. Take Miranda, for instance, often dubbed the Frankenstein moon due to its patchwork surface, which appears to be a mosaic of disparate terrains. Scientists hypothesize that Miranda may have been shattered by a massive impact, only to reassemble itself in a chaotic and jumbled state, creating a surface that tells a story of violent past events. Then there's Ariel, the brightest of Uranus's moons, boasting a smooth, icy surface that is intricately crisscrossed by a network of canyons and valleys. Ariel is thought to have undergone cryovolcanic activity in its past, where water or other volatile substances erupted from its interior, resurfacing the moon and creating its striking landscape. Shifting our focus to Neptune, the sovereign of the deep, we encounter another captivating family of moons. Neptune's largest moon, Triton, stands out as one of the most fascinating objects in our solar system. Triton is unique in that it is the only large moon in our solar system that orbits its parent planet in a retrograde direction, meaning it moves in the opposite direction to Neptune's rotation. This retrograde motion suggests that Triton did not form in the vicinity of Neptune, but was instead captured from the Kuiper Belt, a distant region populated by icy bodies beyond Neptune's orbit. Envision a cosmic game of capture the flag, with Neptune seizing Triton from the Kuiper Belt and making it part of its moon family. Triton is also remarkably cold, with surface temperatures plummeting to -391 degrees Fahrenheit or -235 degrees Celsius. Despite these frigid conditions, Triton is geologically active, featuring geysers that spew nitrogen gas and dust into its tenuous atmosphere, creating a dynamic and ever-changing surface. The moon families of Uranus and Neptune may not be as well known as those orbiting Jupiter and Saturn, but they offer their own unique insights into the formation and evolution of our solar system. Their tilted orbits, diverse compositions, and the potential for hidden subsurface oceans make them compelling targets for future exploration missions. As we continue to probe the outer reaches of our solar system, who knows what other secrets we will unveil about these enigmatic icy giants and their mysterious moon families. So there you have it, a captivating glimpse into the fascinating and intricate world of moon families within our solar system. From the fiery, tumultuous volcanoes of Io, where molten lava flows and eruptions paint a vivid picture of geological activity, to the icy, mysterious geysers of Enceladus, which spew water vapor and organic compounds into space, hinting at the possibility of subsurface oceans, and the retrograde orbit of Triton, Neptune's largest moon, which defies conventional orbital patterns and suggests a complex capture history. These celestial objects continue to captivate our imaginations and challenge our understanding of the cosmos with their diverse characteristics and behaviors. But here's the thing. We've only just scratched the surface of what these moons have to offer in terms of scientific discovery and wonder. With each new mission and observation, whether it's a spacecraft launch or a probe's close encounter, we uncover more secrets about these moon families, revealing hidden features and complex processes that were previously unknown, shedding light on the intricate processes that have shaped our solar system over billions of years, from its chaotic beginnings to its current state. So, the next time you gaze up at the night sky, whether you're alone or with loved ones, remember that those tiny points of light aren't just distant worlds, they are part of a grander cosmic tapestry. They're members of vast and complex families, each with its own unique characteristics, history, and mysteries waiting to be unraveled, each with its own unique story to tell, from surface features to internal compositions and dynamic activities. And as we continue to explore our cosmic neighborhood with ever-advancing technology and curiosity, I have no doubt that these moon families will continue to surprise and amaze us for generations to come, offering endless opportunities for discovery and inspiration. Thank you for watching. Do like, share, and subscribe. Learning Life content.